Let's now look at this first in first out. So it is a queue, right? First in first out means whichever page has entered first into the memory is the first one to leave, right? It is very simple to implement. So anyway, I'm going to show you in data structures how to implement a queue using a linked list. The same concept is used here. So how do we do it is we maintain a linked list in the sense like this. So assume that the page number 1 is the first one to enter the main memory. Then I'll have page number 1, and then let's say page number 3 is the next one to enter, and then page number, let us say 2 is the next one to enter, and page number 4 is the next one to enter the main memory, right? Now let us say this process, and one more thing, every process will have a linked list. So this linked list is specific to a process. So every process which is executing should have that linked list. Now depending on this linked list, a process will generally choose, or a process will generally, whenever you want to try to replace, if we try to replace any page, we are going to go into that particular process linked list, and we are going to replace a page which is allocated to that particular process. And I already told you that there are two types of replacement algorithms. One is global and other is local. Global means whenever we want to replace a page, we can pull out the page from any of the existing process. That is called local. Global means global is we can pull out the page from any of the existing process. Local means whenever a process is running and if it needs a new page, only its pages have to be replaced. That is called local. Let's talk about the local here. And most of the algorithms implement the local replacement, most of the operating systems. Okay, so now what I mean to say is, let us say this is the list of P1, process P1. So whenever process P1 is executing, we'll have only that list corresponding to process P1, and we do the replacement only in the list corresponding to process P1. Let us say process P1 now wants a new page 5. Then what it will try to do is, it will try to replace one of them. Which one? That is why it maintains two pointers. One is head pointer and other is tail pointer. Okay, and now it will try to replace the one which is at the head. The reason is the page which is at the head is the first one to have arrived, right? Therefore we increment this head and now we replace it, and a new one will be added to the tail here, 5. Got it? That is how we keep it updated. Okay, and now in this in the elements of this linked list, the contents that depend on the implementation. Some implementations will take this, some implementations will maintain along with this page number. It will even maintain some information like R bit, M bit, referred bit, modified bit, right? And along with that it will maintain some other parameters like what is the process it belongs to, process ID, and many other things. That depends on the implementation. Okay, and now the main problem of first in first out is, it will never consider whether a page is being recently used or whether a page is being frequently used. It only knows that if a page has entered first, it has to leave first. But because of that, a frequently used page may be thrown out, and it might have to be referred again later, which is going to create a lot of headache. That is why this FIFO has been modified and a new algorithm has been proposed, which is called as second chance algorithm. So this second chance algorithm says this. Let us assume that you are going to replace page number 1 according to FIFO. Now second chance algorithm says that you follow FIFO only, first in first out, but then whenever you try to replace this page, just see its R bit, which means referred or not. In case if it has been referred recently, which means in the last clock cycle it has been referred, then give it one more chance, don't replace it. So second chance algorithm says that if you just take the first one with in the list that has to be replaced, in case if the first one is having or referred bit as 1, in this case you just give it one more chance, because since it has been recently used, there is a chance that it might be used again. So just give it one more chance and then you replace it. So this algorithm says that you just put it at the back. For some time you just put it at the back, just for some, give it one more chance, which means instead of 5 here, 1 will be here. right? And then it will consider the next one to be a valid candidate, I mean a candidate for replacement. And again for the next one also it will check the replacement or bit reference bit, and in case if this one is having reference bit equal to 0, then it will replace 3, not 1. Got it? So this is how every page before being considered for replacement will be given a second chance in case if it has been referred in the last clock cycle, because of which some of the recently used pages will not get out of the memory. It is somewhat intuitively you can feel that it is better than FIFO, isn't it? It is better than FIFO. And the problem with this second chance algorithm is whenever you know that a page is not fit for replacement, whenever you feel that a page has to remain in the main memory, you are actually taking that page and we are going to add it to the end of the list, right? So these page movements are generally unnecessary, I mean they are redundant. Then what people tried to do is they modified it and then they came up with the new algorithm which is called as clock replacement, clock page replacement. And what is this clock page replacement is, we don't maintain the linked list as a single linked list, we maintain it as a circular linked list, which means we maintain it this way, right? And then by using this circular list it is simpler to maintain it. So whenever a page has to be replaced, now let us say this is the front, right? And then somewhere there is tail, okay? Then what we do is whenever we consider any page for replacement, in case if it's r equal to 1, then if it is not the candidate, then we are going to take it to the next one. So generally tail will be immediately the following this head. So what I mean to say is like this. See, now if all these pages are in the main memory and if this is the head of the list, which means the first one to have entered, then whenever it has to be replaced we shall just see whether its r bit equal to 1 or not. In case if its r bit is 1, then it has to be given a second chance. So in order to implement this algorithm, right, we'll just leave this and then we go to the next one and we check if its r bit equal to 1. So we go like this in a clockwise means in this direction until we find any page with r equal to 0 and we replace it, right? And similarly somewhere there will be tail, right? And now whenever you want to add any page, then we are going to add it after the tail bit, right? And we shall see that this tail follows the head. So how is this circular list implemented? Don't worry about it, I'll discuss about this circular list in the data structures. Okay, as of now you just understand that instead of taking out a node from here and putting it at the back, it is better that you maintain it as a circular list so that you can just do like this, like clock, isn't it? So initially this is replacement, this is suitable for replacement. In case if it is r equal to 0, clockwise, then next, then next, then next, right? Likewise you can choose one of them. And how do you add a new one? There you maintain one pointer called as tail, right? In case if all the r's are equal to 1, then what happens is if all the pages have been referred, then obviously we again follow the first in first out. If nothing, if this one starts here and if it doesn't find any one suitable, then again it will come here, then anyways it is going to be replaced. That case is very rare, in the sense whenever we try to replace a page for whenever we try to choose a page for replacement, always we'll have some page which is available at suitable in general at practice. Okay, fine.